Okay, so today I am going to discuss about the application of rolling, right? So this is the problem. I will apply the concept of rolling motion in this problem. So this is the solid sphere of mass m and radius r placed on the top of inclined plane of height h, and we have to find the velocity of this solid sphere at the bottom point, means B point, right? So in this question I will apply conservation of mechanical energy. So first of all, we should know, to apply the conservation of mechanical energy, only conservative field force work. But here solid sphere is also rolling, and in the rolling motion frictional force also support, sometimes frictional force also support the rolling motion. But we will see how frictional force will not involve and how we conserve the mechanical energy even if the internal friction force is applied act during the rolling motion. So let's add at the plane level of the inclined plane. We will take h is equal to 0 and gravitational potential energy is equal to 0 at this level, and the gravitational potential energy of point A, then the gravitational potential energy of at point A is gravitational potential energy at point A is mgh. Now at point A, chunki body is in the totally rest, so rotational energy as well as kinetic energy at point A is 0. Kinetic energy at point A is equal to 0, right? So total mechanical energy at point A is equal to kinetic energy plus gravitational potential energy equal to mgh, right? Now at point B, gravitational potential energy is equal to 0. Chunki we know at the reference point gravitational potential will be 0, and the kinetic energy at point B is rotational kinetic energy as well as translational kinetic energy. Chunki body is rotating about the axis passing through the center of solid sphere, and that axis translate with respect to inclined plane, then total kinetic energy at the bottom of the point is half I omega square plus translational kinetic energy half m v स्क्वायर. चूंकि नाउ मैकेनिकल एनर्जी एट पॉइंट ए इज इक्वल टू मैकेनिकल एनर्जी एट पॉइंट बी. is equal to mgh is equal to half I omega square plus half mv square. And चूँकि we know I is equal moment of inertia is equal to 2 by 5 mr square for solid sphere, and we know the concept of rolling and relation between v and omega. So v is equal to omega into r. V is equal to omega into r. So while putting the values of omega in terms of mass and radius and velocity and values of omega in the v and r, we will get v is equal to under root 10 gh upon 7, right? Okay, so now I am going to discuss about the crux of this problem. चूँकि I have already told sometimes frictional force also support for rolling motion, but if the frictional force support for roll motion, then how mechanical energy is conserved? So the point is, at the point of rolling of body, point is actually doesn't move with respect to contact surface, and hence that frictional force doesn't do any work. That's why total mechanical energy will be conserved. So, and the second thing is if F is a frictional force act at the point, then at the time of rolling, point of application of this frictional force will be remain at rest. That's why this frictional force doesn't do any work. And for pure rolling motion, चूँकि for pure rolling motion, point of contact of the solid sphere at that inclined point should remain at rest, means there is no relative motion between point of solid sphere and the contact point on the inclined plane. That's why frictional force involved even if we will conserve the mechanical energy and frictional force doesn't do any dissipative work. That was the main crux. Okay.